Hey guys, welcome back. In the last video, I started writing a list of all the things I still need to put into the game before I can release the demo version. And just as I suspected, right after I stopped recording, I came up with a bunch of things that should have gone on the list. But for one reason or another, I forgot to put there. So today we're going to talk about one thing that should have gone on the list, and that is AI. Artificial intelligence. And in this case, in particular, the AI of your companions in the game, or NPC AI. And perhaps even more specifically, the driving AI. So the AI system that makes it possible for your companions to get around the game world in their vehicles, or deliver a vehicle to you. Things like that. And I think one reason why I perhaps forgot to put it on the list is that in the game project that I'm currently working on, the one that we call Means, AI is in a much smaller role than in my previous project, Project Slide, so this thing that you're looking at here. And I think the best way to actually get started on this whole topic is to look at what we had before. So for those of you who don't know, this is Project Slide. It's a game project that I worked on for quite some time, using the same engine called Basis that I still use for the current game, Means. And actually one reason why I decided to put this game on hold is that writing a good combat AI turned out to be much more work than I had originally anticipated. Or shall we say a good combat loop, but a large part of that is good combat AI. And Means doesn't really have combat, or at least it's not in as big of a role as it is in this game. So let's see what we have. I have a single player mission running here. We can jump forward in the mission flow a little bit. I have these scripts called jump points. So JP, let's jump until after the combat. And there's going to be some glitches here, things spawning in, and that's just because we're essentially jumping forward in the script. There should be an NPC vehicle spawning in, and there we go. And they're going to drive up to us here. We have a wheel from a vehicle that got blown up because of the scripts as well. Alright, so I'm going to play this mission just a little bit to give you an idea of the dynamic AI that I implemented for this game. So let's pick up this trailer here. And now as we are hauling this trailer away, the other vehicle, the one that we just drove, is controlled by AI. You can see that it now starts to follow us. And basically the AI is now scripted, but it's only scripted to stay close to me. So it's not scripted in the way that it drives, where it drives. It's just given the objective to stay close to me. You can see that if we drive like off-road here, it will continue, or it will follow us, do its best to stay close to, in this case, the trailer. That is the object that it is programmed to stay close to. And occasionally it sort of gets a little too excited and maybe gets stuck somewhere, but it's pretty good at actually staying functional and get itself out of hairy situations. And so this is essentially the kind of AI that I will need for the new game, for Means as well. If we drive forward a little bit, there's a scripted combat encounter here, which we need to be kind of careful not to drive into because we will get obliterated. But you can see that it's now driving off on its own, and it will it will blow that car to pieces. There we go. Good AI. So that was also kind of not scripted. It was only scripted in the sense that the AI vehicles were sort of scripted to target each other, but not more than that. And so that should give you an idea of how these vehicles are actually controlled. So just like we are turning the wheels like this, left and right, and we are applying brakes and accelerating, so too are the AI vehicles. Now that looks like that guy got stuck a little bit, so he's trying his best to get unstuck, and there we go. And now he should try to stay close to us again, and he can do reverse turns and all kinds of things. And so we're not really we're not having the vehicles follow any kind of spline or anything like that, sort of cheating like that, like we are doing, for example, with the monorail in Means, which you can find in a previous video how we did that. That is, of course, a slightly different kind of situation, because the monorail is literally sitting on a rail. We don't want the AI to behave like that. We want it to be sort of dynamic. And so how do we do this? Well, let's shut the game down. We can take a look at a previous YouTube video. So this is actually something that you can find on my channel. Project Slide testing out the new vehicle driving AI. This was a few years ago, actually. You can see that the game is roughly in the same blockout state that we are now with the new project. So this video demonstrates in particular the whisker system. So for this combat vehicle here, you can see these ray casts, these lines that extrude from the front and back. And the whiskers are used to detect dynamic objects that get in the way of the vehicle. So things that aren't found in the nav mesh necessarily. It uses those to detect that, oh, there's something in front of me, to the left or to the right or whatever. In addition to that, it gets its main path from the nav mesh, and you can see that these things are actually cutting holes into the nav mesh, because this vehicle is trying to move around here, and it has a path that leads around that object. But moving objects don't appear in the nav mesh. So that's why it needs to use the nav mesh to get a path, and then a bunch of helper systems that allow it to tackle these special cases. But the main driver is the path that it gets from sampling the nav mesh. And you can see that it renders the path that it is going to take, and it actually constantly resamples the nav mesh as it gets closer. That's why you see these points moving around here. And so something like this should get us pretty far in Means, maybe with some added fixes on top. And so I wrote a very quick spec here. This is not really a spec, this is just some points that I wanted to put down. So we have two parts essentially. We have like the brain, as I call it, which is like the decision making. And in Project Slide, there was actually quite a bit of decision making involved. So for example, you could have an enemy vehicle patrolling an area, and when you approach it, when it spots you, it goes from a patrolling behavior to a combat behavior. And then if it loses track of you, it might go back to the patrolling behavior, that kind of thing. I don't think we will need much of that in Means. There might be a little bit of that as well. Mostly it's probably the case that we have a few behaviors that we want to sort of queue up Things like go here, do that, and then come back. And that logic is typically handled by the system that I've called the brain, at least in Project Slide. And Project Slide uses behavior trees for doing this. And I think it's probably overkill for what we need right now. So I'm gonna try something simpler. So I have another game project that I call Covert, or that was its original name. It was a stealth game that never really got anywhere, to be honest. But it had the beginnings of a pretty nice AI brain system, if you will. Let's open it up quickly and see what we have. So this is in C++, obviously, and means is, or maybe it's not obvious at all, and I apologize for that. But as you can now see, it is in C++, and the current game project is in Zig. That's what we've been doing for a large part of this video series, is rewriting things in Zig. And so we will have to rewrite this system as well in Zig and probably make some improvements as we go. So basically this thing has an action scheduler, and you can have some actions. I didn't actually implement all that many, but we have a few here. We have a move to action, we have an idle action, which, okay, these are just empty files, so idle indeed. We have a scheduler and a factory, and we have a base class for an action like this, right? So essentially we just have one move to action, but this is probably the most important one in means as well. So we can start with that. And the action scheduler has a bunch of layers. So it has a main layer and it has a secondary layer, primary and secondary. The primary layer is essentially a queue or a list of actions that it is carrying out in sequence. And while the primary layer is doing things, the secondary layer can do other things, typically smaller things. They can run sort of in parallel. The action scheduler is the class that is responsible for actually keeping track of these things. So you can see here that we have a bunch of vectors of actions, and we have as many vectors as there are layers, layer count. And you can just run something immediately if you want to, or you can append to the list, which means that it will run it as soon as all the previous actions have finished. I think something like this should be quite good enough for means. And when I say good enough, I say that it will probably actually be a lot nicer to use than behavior trees. I'm not completely sold on the behavior tree idea. I've used them for a few years now, to be honest. Never really gotten super impressed by them. So this should probably be quite nice. Right, so that's the brain. Then we have the driving parts. And the driving system in Project Slide is something that I'm pretty satisfied with. I mean, yes, it does make some silly mistakes now and then. And of course, it also depends on how complex your level is, how fast you allow the vehicles to drive, etc. But I think the system is actually quite good. So I think we're just going to try to actually implement this system in Zig. Basically the things that we already have. So we have a few parts here. We have the whiskers. We looked at that already. We have the drive line. And the drive line is essentially the path that is sampled from the nav mesh, but we do a little bit of massaging the data before we feed it to the vehicle, just so that it has a slightly easier time actually following that path. And the drive line we can actually look here in the I need to open something just to get the proper selection screen. We can just write drive line and we get the class here. So basically you begin, you give it a target position, You give it a distance epsilon, so basically how close it needs to be to the target position to consider being done with the path. And then the vehicle radius, how much space it is requiring to get there. So if it can fit through like narrow passages, things like that. And then you tick it. You give it the current time, you give the vehicle position, orientation, that I've typoed, orientation, all right, and the linear velocity of the vehicle. And what it gives you is a speed multiplier and a steering value. And this is something that you can multiply with your wanted speed. And the steering value is actually the value that you can just feed directly. So it goes between -1 and 1. -1 being steer to the left, and 1 being steer to the right. And of course, this is all considering that there would be no obstacles on the way. So this alone doesn't really, it's not enough, shall we say. We need to have some other helper things on the way. And the said helper things that I have in slide is, first of all, the stuckness detector. And this is simply a class that like looks at where the vehicle is over time, and if it tries to get somewhere, but it clearly can't, then it means that it's gotten stuck, and it will try to do some maneuver to get unstuck. Such as, for example, a reverse turn. So if it tries to run into a wall, then it tries to do a reverse turn and then return to the drive line. Reverse turn detector is another helper system which essentially tells the driving logic whether or not it should stop and make a reverse turn. So for example, if the target is behind the vehicle, according to some limits and conditions, then rather than driving forward, it will actually do a reverse turn and then continue driving forward once it has turned around. And together with this, with all of these parts, you have something called the AI driving component. And this is essentially a component that you can tell, hey, drive here. You can see the interface somewhere. It's right here. So we have just the normal component stuff that you have to have in a basis component: create, destroy, on object created, blueprint properties, updates, ticks, pre-ticks, blah blah blah. But the important thing, or the interesting thing here, is move to. So you simply give it a target position, again the epsilon. Give it a movement profile. We have a few. We have a calm, normal, and fast. So we might want to have something similar in means. Not exactly sure. But in slide, for example, you can have, I think calm is used for the patrolling. So the vehicle is driving decidedly slow around. And the normal and fast, I think fast is used only if it's an enemy vehicle that's like spotted the player. Stuff like that. And then you can actually get a callback here when you have reached that destination. And then you can stop and you can deactivate the AI. If, for example, the player switches vehicles so that suddenly it's the player who is controlling this vehicle, then you want to deactivate the AI. Because, like I said, we're actually issuing control signals. So accelerate, brake, turn left and right. And the player is doing the same. So the car needs to know which orders to follow. And so it typically follows the AI instructions unless the AI is deactivated, in which case the player can then drive normally. And so this is a pretty nice and small and easy to understand interface. I think we should aim to create a similar component in Zig, and that should allow us to basically implement all of the movement that we really want. If we go down here, you can see that we have all of the helpers here. We have the whisker array, which is the array of raycasts in the back and front. We have one front array and one rear. We have the reverse turn logic, stuckness detector, reverse turn detector, and we even have something called a speed lowering logic here, which I didn't remember. Let's see what it actually does. We lower the speed a bit based on the steering value. Right, so if we're steering hard, then we're lowering the speed. If we're traveling forward at reasonably fast speed and steering hard to either side, we start lowering the speed. Yeah, so pretty basic stuff. But anyway, you can almost think of this as like a stack of filters that you take the drivelines input, and the driveline is here as well. Here we go. Take the drivelines inputs, you run it through this set of filters that can do certain things, and then that is applied to the actual vehicle. So there should be something called, is it set input data? Yes. Apply vehicle input. And here we can see, update the input. The steering is piped straight through to the vehicle controller. The other parameters are sent to the auto gearbox, which processes them and update the vehicle input data struct. Right, so we also have the auto gearbox component here. There's something that we already did implement in Zig. We can find it here. Auto gearbox Zig is struct. Oh, that's a params. Here we have the auto gearbox itself, and we quite simply pipe it in, and we get a vehicle input data struct that is updated, and it switches gears, switches between reverse and forward, etc., etc. Things like this. And there's one more thing that I think this actually uses. So speed, yes, vehicle speed controller. So this is almost like the cruise control for your car in the real world. You can set a target, and again, it takes vehicle input data and updates it. And so typically the way that we have the AI adjusted speed is that we use one of these speed controllers, and the AI quite simply tells the speed controller, hey, we want the current speed to be this or that. And then the speed controller is the thing that actually updates this. So it uses a PID controller. So here we go, PID controller, to actually smoothly apply more or less acceleration or even brake, depending on the current error and the current speed, etc., etc. And again, we already have this in Zig. So speed controller. Here we go. And here we have the same thing. So VHL PID controller update. So we actually have quite a few of these already. And I think we can probably actually even try it out here in the game if we want to. So now you can see here it's called CC cruise controllers, target speed 30. And we can just up this to something like 80 or 90. And I'm not pressing the steering or the acceleration now. I'm just steering. So this is essentially how the AIs then could control the speed like this. And of course that doesn't mean that it's trivial. It's still kind of tricky to be able to calculate the target speed that we need for the current place in the world, because it might be affected by a great many things. But still, this is how it works in Slide, and I think it should work pretty nicely here as well. And this system, the cool thing with this system is that it is very sort of reactive. You can make the AI as believable as you want, essentially. But the problem is that it might make mistakes that are kind of silly. So my hope is that now that the driving gameplay in a sense is more simple in Means, because we don't have things like combat or even really enemy. The concept of an enemy here, it's more like a puzzle game than a combat simulator. My hope is that that will make it easier to create driving behavior that isn't sort of annoyingly stupid. It can be sort of funny stupid, and that's much better than annoying stupid. But yes, it is. It's pretty cool that it actually uses the same systems as the player, because that will mean that the cars will sort of slide around and behave just like a physical vehicle will. It doesn't look like it's sort of running on rails, like in some games where they're clearly just following some spline rather than actually driving the vehicles around in a physical manner. This system allows for all the normal particle systems and gearbox switches and everything to be completely accurate, and that's pretty cool. So I have high hopes for this system. I think this is definitely going to be a more tricky and challenging porting operation than some other things that we've done recently, such as the tire trucks, but I think it should be quite a fun little thing to do, and that should then allow me to finally start properly implementing the demo mission, because then we have these NPC cars with the ability to actually drive around and do things, and not just sit here waiting for us to drive them. So that should be fun, and in the next video we will start implementing this. So just an introduction today. But I hope this was interesting. I hope you follow along with the actual implementation in the following videos. And as usual, if you have any questions, suggestions, feedback, anything, write it below. And I hope to see you in the next one. Bye.